viewers, welcome to my channel Mugambe Brian 256. So please guys, subscribe to my channel and like my content. So today we are going to be looking at the heating and the cooling curves. So to start with will be the heating curve, and this heating curve shows us how the temperature of a substance changes over time as it is being heated. And likewise, the cooling curve will show us how the temperatures of a substance keep on dropping as the substance loses heat, well, probably to the surrounding, and then exposed to some other conditions. So, to start with is the heating curve. So, we shall consider a block of ice, and realize that if it's a block of ice, it can so happen that it is negative degrees, and therefore the moment we supply heat, so the temp remember the cooling curve is a graph of temperature against time. So the moment this ice block is heated from the negative temperatures, so we expect, as we supply it, we expect the temperatures to keep rising, and then this temperature, the temperature of the ice block, will rise up to 0 degrees, and at this 0 degrees Celsius, that's when we expect a change of state. Now remember, the ice has been this ice block has been existing as a solid. So at this particular point, when you heat it up to 0 degrees Celsius over time, of course, then at 0 degrees Celsius, we expect a change of state from solid to liquid. And what normally happens at this particular point is that the forces of attraction between the molecules, or between the molecules of this ice block, are just weakened, and therefore there is a transition from solid state to liquid state. However, the temperatures remain constant, and therefore the latent heat of fusion takes place at this particular point. Now, when you supply more heat, after the solid ice has converted its state to liquid, now we expect the temperatures to increase over a given period of time t, until when the temperatures reach 100 degrees Celsius. The moment the temperatures have risen to 100 degrees Celsius, now this liquid now will have to change state from liquid to vapor. However, that occurs at a constant temperature. So we have the latent heat of vaporization taking place here. And at this particular point here, the liquid molecules have gained enough kinetic energy, and then the forces of attraction between the liquid molecules have been completely broken down, and then the atoms or the molecules are free to leave the liquid surface, and then they have been converted to vapor. However, under some conditions of forced pressure, the liquid here, which is water in this particular case, can be heated, and then its temperatures can rise above 100 degrees Celsius, and that is our cooling curve here. Here is a brief explanation of what I've been explaining. Then next, what we shall look at is the cooling curve. Remember, if this water here under some conditions has been heated past 100 degrees Celsius and then we are cooling, that means this water of ours is losing it to the surrounding. Definitely the temperatures have to drop. Now when the temperatures drop from some point above 100 degrees Celsius, so the liquid will cool up to 100 degrees Celsius. Now between points B and C, so we expect a change of state from vapor to liquid, and that occurs at a constant temperature. Now when this liquid now, which is the water, is cooled down, so it can be cooled down from 100 degrees Celsius, and then until when it can drop up to 0 degrees Celsius. The moment it reaches or it hits 0 degrees Celsius over a given period of time, so we expect some change of state to take place, and basically that will be the freezing. Remember, this is the freezing point. If it's a cooling curve, and then from point D to E, so we expect freezing to take place, and the freezing point is 0 degrees Celsius, specifically for water that we are talking about in this particular case. Now, after there have been a change of state from liquid to solid, now this ice, now remember, now this water has been converted to ice. Now this ice can be cooled below 0 degrees Celsius, and hence it can go up to the negatives from between point E and F. So that is our cooling curve. So this is the brief explanation of what I've been talking about. Thank you so much for watching. Please subscribe to my channel, Mugabe Brand 256, and please like my content. Thank you so much.